If you live here in Australia, you live on one of the most vast continents on this planet. It's pretty much impossible to comprehend all of Australia in a single thought. We all know the incredible and complex and intricate beauty that exists between the Indian Ocean and the Pacific Ocean. However, the sheer scale of it means that our little brains can't actually think about it properly. Now, if that's what happens with our country, what about with our universe? How could we possibly comprehend something so utterly vast? And what does it mean for us when we appreciate the scale of it? Thankfully, Professor Brian Greene exists in the same universe that you and I do. He is an absolutely legendary theoretical physicist and author whose latest book, Until the End of Time, Mind, Matter, and Our Search for Meaning in an Evolving Universe, tells a history of our universe from the start to the predicted end. But don't let that scare you, because when you listen to him speak, the reverence, the humility that he has before the florid and glorious beauty and complexity of our universe, from its absolutely most gargantuan structures to the exploration of the 7 extra dimensions that are believed to exist at a quantum level, will leave you with a sense of awe, of wonder, and in some cases, pure joy. To speak with an academic like Brian is an incredible honour. I'm sure that you're going to get as much out of this as I did. Enjoy this conversation with Professor Brian Greene. Thank you so much. Thank you so much for speaking with me today. Thanks to the extraordinary molecule of caffeine, I'm up quite early to speak with you today, which is my favourite molecule, I think. I'm in Sydney, Australia. Where are you, sir?
I am in Manhattan, New York City.
Not a bad spot.
I could show you maybe if I, there's a view out the window there, Hudson River,
And you have an approach, I think if the pandemic taught us everything, it was like, how many things can I get in my bookshelf? But for a theoretical physicist, you have an appropriate amount of books stacked.
Oh, you saw those too?
To the ceiling.
Yeah.
Yeah, I've got so many books, man. I don't even have to get them in shot. My bookcase says I'm smart, but I got even more over here, guys. Mate, it's so exciting that you're coming back to Australia, that you're coming to tour and coming to speak to people with this take that you have on the observable universe that we as humans have, and why it might be interesting to understand that there's bits of it that we can't observe but still affect us. A lot of people appreciate a flower, a beautiful flower. My wife, she studied horticulture. She gets super excited when the flowers arrive, and then I sing Marvin Gaye's Sexual Healing while she pulls one out and then pollinates the other one so we can get some zucchinis. She thinks it's creepy, but I'm like, hey, it's flowers, it's sexy time. But a bee sees a flower completely differently. The bee's optics see there's stripes and shapes and all kinds of things. Is that a way into kind of describing how we as humans appreciate the observable universe, yet understanding there's so much more that we can't quite even comprehend?
Yeah, no, I think it is, because you need to recognize that everything that, we see in the world is dictated by these arbitrary senses that evolution has provided to us. And if we were under different evolutionary pressure, we would have developed other ways of accessing the world. And what we have access to is a tiny piece of a much wider reality. And certainly other life forms do access the world in somewhat different ways. But what science does is it goes beyond what any life form that we're familiar with can do. And it accesses that flower down at the molecules and the atoms and the subatomic particles. And there, the flower is barely recognizable. And yet somehow those particles conspire to yield this macroscopic object that we call the flower,
I wouldn't mind a bit of that ability to see the different spectrums of light. I probably also wouldn't mind a bit of the turtle magnetic detection situation. Like that might be helpful. Certainly when I'm on the motorbike and I can't see the GPS screen and I'm getting lost.
Yeah, and it just shows us how many of us are fooled into thinking that what we see and what we experience is the world. When the reality is, number one, we're seeing a tiny fraction of the whole, a tiny fraction of the spectrum of light, a tiny fraction of the qualities of matter. We only are able to access the qualities of matter on everyday scales, a tiny fraction of the speeds that are possible in the universe, a tiny fraction of the gravitational fields that we never live near a black hole. We don't know what that's like in terms of our inner experience. And the power of science is that it can break free of these arbitrary constraints that come from our particular biological makeup and allow us to imagine what the world is like in places that we can't directly visit.
Look, we're less than 5 minutes in, Brian, but I think I'm going to have to dive in here because what you've just described, the way that we have and I think with you, I can go here because I have heard you speak about this kind of stuff. The observable universe that we as humans have observed has led to, in many ways, the laws and structures that have created the world that we live in. And many of those were, this is all we can see as far as we're concerned. The world ends there at that ocean, and it's like there's dragons over that hill, and here's the rules, and there's a bloke in the sky with a thunderbolt, and if you're a bad person, you're going to get done. And these kind of rules, these theological kind of rules kind of emerged out of this, and they still kind of govern our community today. Some of those laws became secular, but they still exist, written into constitutions and things. What's your hope about trying to open more people's eyes to there's more? Do you want the idea that there's more to kind of find its way into the way our world is governed?
Ideally, it would, because when you have a cosmic perspective, right, a perspective that goes beyond the parochial concerns that are vital, but the parochial concerns of life in your local neighborhood, whether that's truly a neighborhood in the conventional sense, or a city, or a state, or a country, or a continent, or even the entire earth, it's all very local when you think about it from the cosmic perspective. You know, there's the beautiful pale blue dot image that Carl Sagan loved to put forward, where you see Earth floating in the darkness through the diaphanous rings of Saturn, and you realize just how tiny we are. And even that's a tiny piece of a much larger reality. So the point is, if you can acquire the ability to sort of seamlessly transit between parochial concerns that matter to everyday life and these more cosmic considerations, it allows you to put your life in a different framing. And that different framing can be incredibly valuable when you want to live among others who can equally have that cosmic perspective. And things that seem so utterly essential from the parochial perspective is, really? We're really going to fight over this little tiny fraction of a pixel, in the grand cosmic scheme of things? So it doesn't completely change the way you behave, but it adds a layer that I believe in time can soften the things that really divide us, because it allows us to recognize that in the larger scheme, we are all really part of the same whole.
I remember as a kid, right, I went to a school where in every classroom there was literally a statue on a wall of a white bearded man getting horrifically tortured to death on this horrible piece of equipment that involved nails and wood, and there was blood, and every single room had this picture, and they would essentially, or a statue even, and go, yeah, it's your fault that he's like that. And I was a child. It wasn't great. I soon, about 11, I think, I was like, no, I don't think so. And then over time, that separation happened more and more. But I remember observing people who, like grown men in in clothes that resembled dresses, being just so like overwhelmingly reverent to this weird little box in the corner because they truly believed that once they said some magic words, the body of this person would arrive in a piece of bread in that cupboard. And I was like, wow, you are just so prostrate, couldn't believe how much they gave over their agency to this thing.
Yeah.
Now, I have felt that, and I'm probably not going to. I'm preaching to literally preaching to the choir here. Once I started, that pale blue dot image that Carl Sagan spoke about is one thing, but once I started understanding the vastness of what it is and how my very life is dictated by the same laws that keep this liquid in this glass, that stop this glass from falling through my table, that allow the extraordinary electrons that are firing down a fiber optic cable between you and me in New York to happen. Like that is over. Like I am humbled by that. That is unbelievably incredible for me. It's bigger than anything that ultimately could possibly invented by humans, which is what any of those kind of theologies are. Do you remember a moment? Did you ever had a similar experience when you were like first opened your eyes to that?
Well, my upbringing was secular from the get-go. I mean, my parents were devout from the cultural sense to the Jewish faith, but not from a religious sensibility. Coming out of World War II and all the horrific things that happened to the Jewish people. So it was coming from a somewhat different place. But I share the reverence that you describe when it comes to the utterly spectacular qualities of the physical world. And the fact that, as you say, everything is governed, as far as we can tell, by the same physical laws. And those laws perhaps have governed the universe since its inception, maybe 13.8 billion years ago, and have been churning forward and ultimately giving rise to structures like the two of us and the other 8 billion people on the planet. It's just utterly miraculous. But what I would say is, when it comes to religion, I share some of what you're saying, but I also color it in the following way. I also find it utterly remarkable that our species came up with these religious ideas. After all, as Stephen Jay Gould famously said, and I think it's quite accurate, all religions began with an awareness of death. Once we human beings gained mortality awareness, which is not a ubiquitous feature of all life on planet Earth. They're really only us and, maybe elephants to some degree and, some of the great apes. Only some life really thinks about death in one way or another. And I think our thinking about it is the most refined of any species on the planet. And once we realize that we're going to die, that is a potentially debilitating recognition that everything we do, everything we care about is going to disintegrate, is going to be gone. And that could have reduced us to what some researchers describe as quivering piles of protoplasm quickly en route to extinction, right? But we invented ways to deal with that recognition, and religion is one of them. We invented this idea that maybe death is not the end. Maybe there is something else. And look at the power of that idea to motivate people and to meld people into groups. Now, it's not always good, right? I mean, there are some pretty negative consequences of this particular way of dealing with our recognition of our own mortality. But there are also some absolutely spectacular qualities, some deeply motivating and moving qualities of feeling part of something even larger than life on planet Earth. So I see it as a good example of what we're capable of, what our imagination is capable of. And when seen in that light, I don't have as negative a ubiquitous and universal reaction to these ideas.
I share the idea of the positivity that many religions have brought our world. You may guessed by the last name Ginsburg that there is some Judaism in my heritage, and in many ways I definitely identified with the secular traditions that you spoke about, the idea of, getting together on a Friday and, giving to charity and keeping a seat at a table. Like that sort of thing is an extraordinary kind of built-in community cohesion that is built into tradition and was coupled with, this kind of divinity, and then for some people has separated. So there's many religions that do have that, Friday prayers in Islam, et cetera, et cetera. For me, it's when the humans get involved and kind of pollute that. And as you mentioned, start to go, well, we're clearly better than those guys. So therefore we get to be here and you don't. And I don't know, but as you mentioned, it's like, why are we fighting over this tiny little bit? We're all here. To take it even further, and I don't think I've spoken a little bit about this before. Holy shit. I'm just looking at the date. Today is my 13th sobriety birthday. There you go.
Oh, is that right? Congratulations.
Yeah. Mate, it's the thing. It's just day at a time. And part of being in the particular fellowship of sobriety that I'm part of, it is a acceptance of something bigger than you, a higher power, they call it. I had a real problem with the word God. I chose physics. I chose the universe. There is nothing more, like I cannot possibly be bigger than this thing. And once that unlocked, it was super easy for me. And and I've kind of had that. So I guess I'm kind of cheating with how reverent I am towards it, Brian, because it is something that I really think about quite a bit. But it is just something that, you talked about the solution of death as what religions kind of came up with. Like the idea that this kind of collection of atoms, pretty much none of them were there when I got born. It's all bits of food and air that I've breathed in that I'm just kind of carrying in this kind of clump that will eventually go back to being, plants and trees and just meld back into this giant bit of plasticine that becomes the planet and the universe. That is amazing for me.
Yeah, it's totally amazing. And the other related side of it, which is another way of describing my thoughts on religion, is that I revere the physical universe. I revere the laws of Maxwell and Einstein. I don't know if they're the final word. I think that they're probably not, but we're en route to a deep understanding of the laws that govern everything. And the fact that those laws can govern particles to come together in a brain that can somehow achieve conscious self-awareness. So it's the conscious self-awareness side of things, that inner world that is as spectacular as the outer world that, we've been really successful at describing using mathematics. The fact that we do have these inner worlds, and those inner worlds can imagine things that are not really out there in the world, that we can use creativity and the power of emotion and observation to come up with ideas like a God, or ideas like Beethoven's Ninth Symphony, or ideas like the Mona Lisa that we can execute in works that can speak to us in ways that pure language can't, that mathematics can't. That to me is another side of what really is deserving of that sense of awe and wonder.
I think it's Brian Cox who says it's three simple words, but it blows my mind. Atoms contemplating atoms.
Yeah. And how is that even possible?
Yeah, I know. I listen to Sam Harris sometimes and he goes, just sit in your consciousness. What? The way he kind of whispers in my ears, it's wonderful. While our brains did come up with this idea of a God, and there's ideas that our brains are kind of wired for a divine being that are, somehow being explored. We're also limited in our ability to conceive of some things, some concepts. Vastness is one of them. Even the vastness of our own country, or the vastness of our own population, the vastness of our atmosphere. These things are rapidly pushing us towards a fairly simply explainable and quite predictable conclusion. How are we possibly able to contemplate the vastness of space or the infinitely tiny, quarks and things that roll around inside your strings, if we can't get our heads around the idea of hot, if we burn this thing, it puts too much of that in the air. Too much of that in the air means we can't eat any food. No food, we die. Oh, get back in my car. Like, what are we going to do, Brian?
Yeah, well, I don't know that I would compare the qualities necessary to fully embrace, say, the cosmos and the scales that have been revealed through powerful telescopes and powerful mathematical analyses, and the consequences of our actions here on Earth. Because frankly, I think most people are able to grasp at least the idea of what you're describing, that doing X is not good for Y, and Y has to do with our survival. I think people grasp that, but they don't absorb it deeply because of the timescales involved. And because the timescales are such that we're not likely to bear the worst burden of the consequences of today's actions. At least, maybe the younger generation will, but for those who are of an age that they are driving cars and have been driving cars for decades already, it's really hard to absorb the consequences that you are unlikely to ever directly experience. And that is just a quality of the human mind that we need to battle against. Now look, there's an evolutionary way of thinking about this, which is, we're programmed to survive as individuals, and the degree to which we needed to plan and think about things 40, 50, 100 years into the future as our brains were developing in the African savannah, we didn't need to do that. We just needed to survive till the next day and the next day after that. And so we've gotten pretty good at ensuring that day by day we're going to be okay. And we're really bad at seeing, say, an exponentially growing curve that suggests that we're not going to be around much longer. Look, even with the virus, we saw this. The virus exponentially growing in terms of the amount of infection, which means that to handle it, you've got to act immediately. You've got to act before there's an issue, before there's a big problem. Once there's a big problem, the exponential growth is on its way and you've lost the game. It's really hard for us to think in those terms.
And you mentioned, we're talking about climate change. We're talking about the pandemic of 2020, 2022, 23. For people who are listening in 5 years from now, or 10 or whatever. When those things happen, or, the vast amounts of communication sort of happen around that, we start to see almost this weaponized science denial. And my palm and forehead equally hurt in measure from the amount of head slapping that I was doing. Brian, when you are speaking with people who are in denial of science, what do you find is the best way forward?
Well, I can tell you what the worst way forward is, which I've seen some of my colleagues, some well-known colleagues do, which in gross description is to try to tell people that they're stupid. Say, hey, you're just dumb. You don't get it. And obviously, that might momentarily make the speaker feel a sense of, I have done one for science. But in reality, they've not, because it just polarizes people even more. Yeah. Because typically, people who are science deniers, I have found, are not denying science because they've thought about it. They're not denying science because they went through some kind of rigorous analysis of the ideas and the data, and they just came to a different conclusion than the rest of it. That's not what's happening. Science deniers are denying science because of the group to which they associate, and their identity is bound up with that group, and that group has taken a stance of denying what the ideas of science for whatever reason, typically because there's a sense of dissatisfaction with the status quo, a sense of fighting against the powers that be, and science somehow is identified with those powers. And so it has nothing to do with analysis of the ideas and everything to do with the ways in which people are unhappy with their circumstance. So the only way to really deal with this is to deal with the circumstances that have led to that kind of sense of we need to fight against the establishment. We need to fight against those who want to keep us down. It is not a matter of better science education. Look, for some, I hate to speak in generalities. For some people,
Yeah.
you sit them down, you explain the ideas, they'll get it better than they did before, and maybe they'll say, oh, now I agree with you. I think that's pretty rare. I think the way to deal with this over a large scale is not so much with the scientific ideas, but really listening to why people feel that they have not gotten their fair share, why they feel they've gotten the short end of the stick, and try to bridge the gap between where they are and where they want to be.
That's an extraordinarily compassionate answer, full of empathy, and I have certainly been guilty of engaging in, mate, you're an idiot, early on.
And how did that go? Right.
I quickly came to the conclusion that no one's ever going to change their mind in a Facebook comments box ever. So don't bother. Try and find a way to, as you mentioned, try and find a way to understand, like, why is it you believe that what I have to say is a direct attack on you? It isn't.
Yeah.
We're just talking about, a law of thermodynamics that has nothing to do with either of us. And, how do we get to that, an agreement point there? Though it can be an enormous waste of time to get that far with people, unfortunately. But as my brother would say, your garden, your path. And it's, can be hard sometimes.
Yeah.
When it comes to the kind of curiosity that it takes to engage with those kind of conversations, though, we are all curious as kids. We have two. One's just turned 19, the other one's 3.5, and I see curiosity in both of them. One of them's just she's really engaged with university. The other one's just really engaged with like the world, and it's unbelievable to watch both of them. I understand that we're quite lucky to have two kids that are quite curious. And your experience, what happens to our curiosity as we get older?
Oftentimes it evaporates because, at least in the educational system here, and I suspect it's probably not much different anywhere else in the world, there is such a focus on evaluation. There's such a focus on assessment that the joy of curiosity really gets flattened under the incredible weight of anxiety, the anxiety to do well. And the reason one is trying to do well is generally not to understand the wonder of the ideas, but rather to get ahead, to climb that ladder one rung higher, to do well early on, to go to the university you want to go to. Why do you want to go to the university? Because I want to get the job. Why do you want that job? Because I want to make the money. I want the stuff. I mean, there's a tendency for that trajectory to take over. Obviously, it doesn't take over for everybody, but it's a fairly dominant quality, at least that I have seen in, for instance, the schools that my kids go to and the schools that I have spoken. Again, I don't like to speak in universals and generalities because there are some wonderful teachers out there and some wonderful schools out there, and they know who they are. If they're listening to this, thank God you all exist. But it's not the norm. It's not the average. It's not the status quo in many of these schools. And so what's the answer? Well, I don't fully know what the answer is, but I suspect that 1,000 years from now, assuming that we're still here, education will, and maybe even sooner, maybe it's 10 years away with everything that's happening in artificial intelligence, but we need an education system that is not a one-size-fits-all approach. I think that's the problem. We've been teaching one-size-fits-all for a really long time. One teacher, bunch of students. And, your style and your approach as a teacher will reach some of those students, hopefully, but it's not going to reach all of them. And what you really need is an approach where the pedagogy is so carefully crafted to meet the student where they are, which is a function of their upbringing and where they grew up and what kind of friends and what kind of parents and what kind of previous teachers. And if you can just sort of reach the kid where they are, the pedagogy and the student can lock in a way that can allow the curiosity that you started the question with to flourish and to flower. But without that, I think it's hit or miss. And for some students, the curiosity will just be ignited by what the teacher's saying. But what I found is that for many, that won't be the case.
And to hark back a little bit, that sometimes that curiosity can definitely be ignited by what's called rabbit holing and spending way too long on YouTube because suddenly it's all very interesting all of a sudden, where previously it wasn't engaging. As we get older, the science is clear that no matter how sedentary you've been, if you start moving, you'll move more, and your quality of life and your experience of the world, your way your head works, way your body works, will all be better to be it, and your experience of your vitality will thrive. Sorry, it's on my brain. I've had some shitty hip surgery recently, so I'm spending a lot of time in physio places where I'm the youngest person there by about 30 years. So it's kind of interesting. Do you think that as adults who might be listening to this going, I'm not curious at all, I listen to the same songs I listened to when I was 20, I watch the same shows every night, this is it. Do you think as adults we have something to benefit by engaging our curiosity in a similar way, that we might start to move our bodies in ways that we haven't for a long time?
Well, it's funny that you mentioned that, because I too have been suffering back problems and sciatica. I guess man. It's just the sort of thing that happens. And I finally decided to not do what I thought was the right thing, which is like, let it heal, sit still until it's better. And I just decided to try to push through it. And so far, I mean, who knows, it could be tomorrow that I can't move again, but so far, just getting up and moving and breaking free of what I was doing before is making, all the difference in the world. And I kind of see that almost as a metaphor. I mean, it's a literal kind of activity, of course, but I see it as a metaphor for kind of what we should be doing with our minds. If you can shake free of the mindset that you have been in, perhaps for a long period of time, by just doing different things with your mind, thinking about different things, engaging with the world in a different way. If you never wrote, start to write. If you never did any math, do a little bit of math. If you never painted, do so. Anything like that, I think, can just shake up the way that you may have become entrenched in one way of looking at the world. And as we said in the very first question, if you can engage with the world differently, it will enhance and deepen the way that you feel connected with the larger reality. So yeah, I think mind and body, it's critical in order to stay nimble, that we don't simply do the same thing over and over again.
Just walking around with Wolfie when he was really little, his teacher said, like, whatever your words you give him now, he'll start using in a year from now. So I'd be walking around the block and it's not a tree. It's like, there's a melaleuca. That's a eucalypt. That's a red eucalypt. There's a banksia. Oh, it's a bottle. And just like, I would seriously, Brian, like just 10 minutes of that, just observing my neighborhood, I would come back to my house and I would be like, what just happened? I felt like I'd had another cup of coffee, which is usually too many. And it was extraordinary how much my brain just woke up and started to look at things differently and observe things differently and solve problems differently and now I do that every day, and my life has changed in wonderful ways because of it. You work, or largely you're very famously known for talking about string theory, quantum physics, which for many people is like, well, that's a thing that is like, I don't have a telescope big enough or a microscope small enough to observe this thing. We're talking about particles that's smaller than quarks. Are there any kind of things that we can look around our world that we can observe that can show us evidence of quantum physics and start to kind of scratch that a little bit?
It's tough. I mean, in some sense, part of the beauty of quantum mechanics is that it does talk about a realm that's so far beyond what we can directly perceive. And yet, once we understand that realm, we can then make predictions about things in the real world that we can see, even though we need mathematics and very high-powered equipment to bridge the gap between the two. But I mean, one should note that without quantum physics, we would not be able to manipulate the motion of little particles. Among the ones that you mentioned are electrons, which of course is how we get electric currents. We would not be able to manipulate them through tiny integrated circuits. And without the integrated circuits, there'd be no chips. And without the integrated circuit, therefore, there'd be none of the technology that has radically transformed how each and every one of us lives. No personal computers, no cell phones, none of that. None of it would exist. In fact, you can estimate that a significant fraction of the world's gross product, right? Take it to America, the gross national product of America is reliant on the electronics industry, and the electronics industry is reliant on quantum mechanics. So if you ask, where can I see quantum mechanics at work? You see it at work everywhere around you, even though you can't peer with your naked eye and see the motion of those electrons. Without our understanding of how they behave, which comes from quantum physics, we would not be able to control them in the manner that is required.
We all understand. We've seen it's a drawing because we can't find a picture of it. There's a nucleus and there's things orbiting it. It looks like a tiny little solar system, like flying around. Sometimes there's more things in those orbits. Sometimes there's less things in those orbits. And the stuff you're talking about is smaller than the things that make up the things we're seeing flying around in those circles.
Well, the electrons usually would be the things flying around in the circles, although the flying around in circles is an approximation that is pretty misleading if you actually understand the theory a little bit more deeply. It's more like a cloud of electrons whose positions are nebulous because of the uncertainty principle of quantum mechanics. But yes, that's the scale at which we're talking about. You know, atoms are roughly 10 to the minus 10 meters across. I mean, 10 to the minus 10, right? That's so tiny. Decimal point with, all these zeros and a one after it. It's well beyond anything that we've experienced. And the electrons themselves, we don't know how big they are. They could potentially have effectively no size at all. They could really be fundamental in the most fundamental use of that terminology. But yes, those are the kinds of things that are racing through integrated circuits and making the electronics that we have around us do what we want them to do. And it took a generation of scientists from about 1905 is when Albert Einstein writes what effectively is, say, the second paper on quantum mechanics. Max Planck writes the first one about 1900. Einstein writes the second pivotal paper. So it takes from there until about 1926 before somebody else named Erwin Schrödinger writes down an equation that describes these qualities of the microscopic realm, Schrödinger's equation. And then from there, it's a good, 60 years later where people go from basic understanding to leveraging that understanding to apply it to do things. And so it's a wonderful story of completely theoretical, mathematical ideas trying to explain some pretty esoteric data that comes out of experiments that were taking place in the early part of the 1900s to something that changes life. So it's esoteric in 1900, and it is life-changing by the time you get to our current era.
Schrödinger is a good swear word to yell as you reach your USB cable around the side of your laptop and only find out if you've got it the right way around upon experimenting.
Yes, exactly.
It's the USB superposition. It's a beautiful thing.
Yes.
It's always a beautiful thing. Once we start getting down to this level, though, this tiny, tiny level, there's stuff that is absolutely mind-boggling. Like, I believe it's called spooky action at a distance, how two particles that as humans, I was talking about this with my wife at dinner last night, like as a human, I can only perceive that something could move, or I could interact with an object if I can either touch it or exert a force upon it. And far enough away, like a bullet or something like that, I can exert a force upon an object. That's about it. I'm going to have to fire a rocket at an asteroid to move it. But the idea that two particles, smaller than anything so many zeros, can interact with each other from miles away, that's pretty interesting. How do we even get our heads around that? Can you talk me through that?
It's very interesting because when I took quantum mechanics as an undergraduate, I'm getting up there in years now, but I took quantum mechanics as an undergraduate in the 1980s. And this idea of spooky action that you're talking about is called quantum entanglement, is the more precise terminology. It was never mentioned in the class on quantum mechanics. So kind of in the early days of people coming to grips with quantum mechanics, I think the other qualities of quantum mechanics, the fact that it describes the world's evolution in terms of probabilities instead of definite outcomes, people had to grapple with a radically new way of thinking about the world. Maybe they weren't ready to take on quantum entanglement, but now quantum entanglement has rightly assumed its place at the center of the subject. And this is something that Schrödinger himself predicted way back in the late 20s, early 30s. He described quantum entanglement as the centerpiece of quantum mechanics, even if people weren't really paying attention. Einstein himself was so offended by the possibility of quantum entanglement that two particles, as you say, arbitrarily far apart, that had interacted in the past in the right way, but they're now arbitrarily far apart. They act as though they are one. They act as though they are one, even though they could really be on opposite sides of the universe. And Einstein said, come on, that can't possibly be how the world really works. This must be a failure of quantum mechanics if it is saying that this is how things behave. Nonsense, he said. In fact, he wrote a beautiful paper in 1935 with two colleagues, Podolsky and Rosen, where he laid out an alternative view for why two distant objects might seemingly behave as though they are one, but they're not really. It was this alternate approach. And that alternate approach ultimately gave rise to a prediction that could be tested in an experiment. This is the insight of a physicist named John Bell. And when it was tested, Einstein's proposal failed. It didn't work. In fact, this weird quality of quantum mechanics that distant objects really can behave as though they are one, it was confirmed by the experiment. Einstein was already gone by that point. This is in the early 60s. And as you may know, it was this year the Nobel Prize was awarded for work on quantum entanglement. So this is now mainstream physics. How do you wrap your mind around it? It's pretty tough because it's so unfamiliar. Look, Einstein had a pretty agile mind and he couldn't really fully wrap his mind around. I mean, he understood it. Don't get me wrong. He couldn't accept it. That's how foreign it seemed to him. Now, you know how it works. Something that's foreign to one generation, it becomes commonplace to the next generation, right? I mean, imagine trying to describe what we're doing right now, having this conversation on opposite ends of the world in real time. Imagine trying to explain that, to one of our forebears 10,000 years ago. They'd be like, what are you talking about? That's nuttiness. But things that are nutty at one time become, blasé. We become blasé about it in the future. We are now not arguing about quantum entanglement. We're now leveraging it to build things like quantum computers. So quantum computers make use of quantum entanglement in a fundamental way. And quantum computers are real. And they're just really starting to have a revolutionary impact on the kinds of calculations that we do. But quantum computers are applied quantum entanglement. It's no longer something we argue about. It's something that we just use.
Are we playing with stuff we don't quite understand, or just like, they work this way?
It's a good question. And I don't mean to sound overly philosophical, but it does depend on what you mean by understand. If you mean by understand that we have a deep intuitive sense of why something is true, then I would say maybe we don't fully understand quantum entanglement. But there's another type of understanding, which is you say to yourself, I know that my intuition was only built through evolutionary processes to understand the things that my intuition needed to understand so I could survive. And our forebears didn't need to understand quantum entanglement, and that's why it's foreign to our intuition. I'm going to accept that. I will thereby change my definition of understand to not be, I have a deep intuitive sense of why it's true, and rather change it to, do I have a deep mathematical handle on this phenomenon, allowing me to make predictions that I can test in the laboratory. And if my predictions are borne out by the experiments, I will say I understand it. If I can make predictions that are true and I can do things, then I understand it. So at that level, the answer is yes, we do understand it. But no, I can't say that if you were to wake me at 3 o'clock or 4 o'clock in the morning and say, quantum entanglement, do you feel it in your bones? I suspect I'll say, I'm still struggling to get that one in my bones.
But I'm still struggling to get past the Buckaroo Bonsai's fourth dimension. I like to get to 10 dimensions. That's beyond what my brain can kind of think about. I say this a lot. I talk about it with sobriety as like, the idea that if I could ever live life without alcohol, it'd be like if I asked you to come over and meet the kids, but I blindfolded you and said, now describe to me the cars on the street. You'd be like, well, I know they're there, but and there's this empty thought bubble where the answer should be. Like similarly, I can perceive 3, up, down, left, right, here, there, 4, 5, 10. My brain just stops working around that point. What are the repercussions of 10 dimensions on my life, Brian?
Well, first I should say you're not alone in not being able to really picture or think about 10 dimensions. I can't either, and I've worked on the subject for close to 40 years. So there are very few, if any, human beings that can really picture it. There's sort of a fun story of a mathematician at Princeton, whether this is apocryphal or true, I don't really know. But the story goes that he's lecturing on 6-dimensional spaces to a class of students at Princeton. He looks at their faces and he sees they're not understanding. So he walks to the corner of the room and kind of thinks it through, and he comes back and says, aha, I get it. It's just very hard to picture in 6 dimensions, but it's really easy to picture in 12 dimensions. Now I suspect that's just a story, but who knows? But what do? We again use our mathematics, and mathematics is a very powerful tool for describing things that the human brain can't directly see. And again, we see in 3 dimensions, presumably because our world only has 3 big dimensions that we need to navigate in everyday life. That's, left, right, back, forth, up, down. As you say, those are the 3 that are easy to see. And they're easy because our brains were under evolutionary pressure to survive. And to survive, they needed to navigate the dimensions that are all around us. But that doesn't mean that there can't be other dimensions tightly curled up, very small, so small that the eye can't directly perceive them and our bodies don't directly move through them. And therefore, survival has nothing to do with these extra dimensions. And yet they're there. So sort of the best we can do is use math and analogies. Analogies are really good too. I mean, one that I'm fond of, imagine you have a garden hose and you are looking at that garden hose stretched out from a kilometer away, a mile away or so. From that distant vantage point, that garden hose stretched out is going to look like a line. You're going to think it only has one dimension, back and forth. If you imagine a little ant on the garden hose, you will think that the ant can only walk back and forth. That's all that's available to the ant on the garden hose. But then if you take a pair of binoculars and you zoom in on the garden hose, another dimension becomes visible, a curled up circular dimension, the girth of the garden hose that wraps around the garden hose. And now you realize that the ant can not only walk back and forth, but it can also walk around the garden hose, a second curled up dimension that you didn't know about from a distant vantage point. And maybe the garden hose example describes our universe. The back and forth of the garden hose, the big dimension, is like left, right, back, forth, up, down, the big dimensions that we experience. And maybe just as the ant has an additional curled up tiny dimension available to it. Maybe our world has additional curled up tiny dimensions too. They're just so tiny that we've never seen them and we've never directly accessed them. You might say, okay, then why in the world would you talk about them? And the answer is, when you want to go beyond Einstein, when you want to go beyond quantum mechanics, the mathematics almost ineluctably leads you to the need for extra dimensions of space beyond the ones that we directly experience. And that's why we take these ideas seriously, even though we've never seen these extra dimensions.
The idea that, like, to have you even just say, oh, they tested Einstein's theory and it didn't work. You know, we brought up with this idea that we associate this name with super smart, always right. You know, the idea that these unbelievably clever physicists can have their math start to not work once they get to certain, you know, trying to find the answers to certain things is wild.
And important.
Yes. And then I used to speak about this with Matt. He was one of the people that worked on a show I was in. He was the first person we talked about Big Bang, which is who knows what, then explosion, and then expansion. We're just constantly expanding. Then he says, oh, but you haven't heard about the Big Bounce. I was like, what's that? And he's like, well, everything goes out, then it comes back, then it goes out, then it comes back, goes out, and we're in the trillionth iteration of that. And I kind of like I looked up and to the right for about 5 minutes as my brain tried to pull that together. And then the one the other day, this idea that there is Turok, I think. There's like, we are in this version going this way, but there's an equal mirror one going that way. And then the idea was that, oh, now the maths works. The idea that you as physicists just question each other all the time. Like if my wife questions me, I'm like, what are you talking about? Like, I hold on to my truth. You know, how do you as, you know, this super esteemed world famous physicist, how do you deal with people going, Brian, you got that one wrong?
Well, most of the time we get things wrong. I think that's sort of important to know. I don't mean wrong in terms of making a mistake, even though that does happen on occasion. But, you know, 99.9% of our ideas are wrong in the sense that they're not relevant to reality. The number of papers that we physicists publish versus the number of those papers that really matter to a deep understanding of the world, you know, it's a really high ratio of failures in terms of that measure of success being, does it actually describe the real world? So we are constantly open to being wrong because we are wrong most of the time. So it's not an unfamiliar place to be. But Einstein, I think, provides a really good example. So, you know, he writes down his equations of general relativity in 1915. In 1927, he's confronted by a Belgian priest named Georges Lemaitre, who says, Einstein, I've applied your equations to the entire universe, and space should be expanding according to your equations, Dr. Einstein. And Einstein says to Lemaitre, your calculations are correct, but your physics is abominable. Einstein was saying, there is no such thing as an expanding universe. That's nonsense. And then a few years later, Edwin Hubble, using the powerful telescope at Mount Wilson Observatory, finds that the distant galaxies are all rushing away. The universe is expanding. And what does Einstein do? He does an about face and says, I got it wrong. I didn't even trust my own equations, the consequences of my own mathematics he didn't trust. But it's hard to have a flexible mind on every aspect of the world. And this is not an isolated example on other things too. Einstein didn't believe in black holes. They weren't called that back then, but he didn't believe what we now call black holes exist. He was really on the fence as to whether ripples in the fabric of space could ever happen. These are so-called gravitational waves. But, you know, in 2015, we detected the first ripples in the fabric of space, gravitational waves. You know, the Nobel Prize a couple of years ago was for detailed observations establishing that black holes are real. And now the Event Horizon Telescope, this consortium of radio telescopes around the world, they've seen black holes directly. We have pictures of black holes. That's an amazing thing. And again, Einstein didn't know that this is how the world works.
So you're saying that Einstein might have found the same thing and gone, yeah, that can't be right.
Yeah.
And then stuck with this. No, it's as it is. There's something to learn from that, I think.
Hugely to learn from that.
Yeah.
Like you say, if someone like Einstein can be wrong and wrong repeatedly, you just have to have great respect for the universe and its immense subtleties, and to recognize that the human brain is a deeply valuable guide to the nature of the world. And the fact that we can get as far as we have as a community is wondrous.
I got to thank, I believe it was Stan Lee, the great comic publisher of the 50s, 60s, 70s, and now movie mogul, even though he's no longer with us. Because as a teenager, as a young teenager, on Monday of one week, I would read about Peter Parker, the Spectacular Spider-Man, and the following Monday, I would read about the Amazing Spider-Man, and then there was another one that I believe, then it was X-Men the following Monday after that, which Spider-Man also appeared in the same timeline. Completely different characters, same dude, and I guess it helped me get my head around this kind of this multiverse scenario. What has that kind of idea gotten right about the multiverse? What are some gaps we need to fill in?
Well, there are a lot of gaps, and look, I don't take exception to creative artists taking poetic license with some of the ideas that physics has come up with. But the idea of a multiverse is not a single idea. There are many flavors of the multiverse that science has come to. Two, perhaps, are worth quickly describing. One has to do with the Big Bang. And the Big Bang, our theory suggests, may not have been a one-time event. There may be many Big Bangs giving rise to their own realms of expanding space, with our expanding space just being sort of one bubble universe in a grand cosmic bath of other bubble universes populating this larger landscape of reality that has multiple universes. Therefore, calling it a multiverse is a sensible idea. Another way that this notion comes up has to do with quantum physics, what we were talking about before. Once we learn that the world, according to quantum mechanics, evolves in a probabilistic manner, say, where the equations say there's a 50% chance of the electron being here and a 50% chance of it being over there, when we actually measure the electron, we always find it either there or over there. We never find half of it in each place. It's always one or the other. So the question is, when you measure the electron, what happens to the other possibility? Well, one idea that people have come up with is that other possibility does happen. It does take place, but in another universe. And in that other universe, you find it at that other location. So there are many yous with many realities, with every possibility allowed by the quantum mechanical laws being realized in its own separate realm. They might say, that's a pretty extravagant way of dealing with this probabilistic nature of quantum mechanics, and this is something that you'll just have to take my word on. I don't like forcing you to take my word on many things, but this one is hard if you don't know the math. From the mathematical standpoint, this is the most economical way of interpreting the equations that Schrödinger wrote down way back in the 1920s. So the most economical interpretation of the math of quantum mechanics is that there are many realities in which each of the possibilities allowed by the quantum math actually takes place.
As you were speaking, Brian, it felt like, again, when I'm at my rehab physio and they're making my glute med try and stretch in ways it hasn't done so in years, I can feel neurons in my brain forging new neural pathways like a fucking icebreaker across my concept of like just cracking things apart. I'm trying to follow you as I'm feeling literal blooms explode in bits of different lobes of my brain. It's wonderful. Yeah. And I can't wait to see you do this live because I might just jump out of my chair and shout, but I won't. I promise I won't. You say this beautiful line, life is physics orchestrated. And hearing everything you've just said about multiverses and like that, like, mate, it's 5 to 10. I've got to get the kid to swimming, and I've got to do this, and I've got to get that. Blah 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 blah. Brian, what has this got to do with me and my life? Sure, there's 17 versions of me, but that none of them have to get the groceries right now. There's too much laundry, and my boss is giving me the shits. Like, what does all this have to do with us in our everyday, just trying to get through the system that we call life today?
Well, it's two things. One is it shows the amazing capacity of the human mind to penetrate into obscure qualities of reality. And that to me is deeply thrilling in its own right. But for those who are not moved by that particular perspective, what this all means is that we are part of a much grander whole. There's so much more to reality than the everyday. And you have to deal with the everyday. I too, dropping my kids off at school when they were younger, walking the dogs, which I have to do shortly after we conclude our conversation. All the everyday stuff, yeah, it does.
You'll be trusting the atomic bonds in the plastic bag as you reach down to pick up dog shit off the streets of Manhattan.
That's exactly right. That's exactly right. But the point is, while all of that is vital and important, it's only one layer of life. It's only one layer of reality. And if you can grasp these ideas, they allow you to live on multiple planes. There's the plane of everyday life, really important, but there's also the plane that takes a step back and recognizes that we are part of this grander whole described by the laws of physics. And there are other layers too, where we recognize the power of the human mind to create, great beauty, to illuminate spectacular wonder, to give us a sense of connection to an even bigger reality. And the fact that we bags of particles, which really is all that we are, the fact that bags of particles can do all that is so spectacularly gratifying that if you can catch a glimpse of this, it just adds so much wonder to your own life while you're dropping off your kids or walking the dog or getting the groceries, to in parallel with that, see the world from a cosmic point of view.
It certainly has helped me when I have been struggling. I know I've struggled quite a bit at some point in my life. I got quite mentally unwell at one point in my life. The ideas that, I'm just this tiny itty bitty thing, that the vastness of this problem, this particular thing that I am thinking means the universe, actually doesn't. For a while, I needed meds to help my brain get to that point. But now I'm able to, if I can catch myself in the moment, go, oh, actually, in 5 minutes, this will be different. And then it's been really helpful.
Yeah. It's not only really helpful, some people hear the description that you just gave, and they said how depressing it must be to think of ourselves as these little tiny creatures in this vast darkness of the cosmos. How frightening that sounds. But I like to flip it around and say how spectacular it is that these little tiny creatures can get to the point of recognizing their connection to this grander whole and to appreciate the fleeting moment that the laws of physics allow them to exist. And that is cause for celebration as opposed to a dark view of reality.
Mate, when I am walking now, we both walk past a melaleuca tree, and Wolfie and I smell the blossoms because it's the time of year when the melaleucas blossom. It makes those moments just absolutely crystally perfectly pristine.
Yeah.
And if I'm lucky enough to get all the other shit out of my head and I can have this moment with my boy who will never be this small ever again, that's the stuff. It makes my heart warm even just talking to you about it. And for me, it enhances my experience of being human.
Yeah, it's exactly right.
Brian, I can't wait to see you come play like you've got a band. Though you should consider taking a band. I mean, it would be really good. Difficult to tour, though. It's expensive. A lot of costs when you're housing 10 people. But come on, your talk with a bloke and a gong, come on.
Yes,
it'd be great.
That'll be the next incarnation.
Yeah.
This is the unplugged. This is the unplugged version.
Wild. Brian, you're too good to me. Thank you so much for your time.
My pleasure. Great talking to you.